Welcome to Drone Recipe. My name is Peter. I'm the host for the show. Today we're going to be doing a 4-inch quadcopter build. This is a 150mm frame made by FrSky, and I believe there's RealAct that also makes a copy of this. I'm not sure of any others. The other main parts I'm going to be using are Brotherhobby T1 Tornado brushless motors, and these are 1407 4000 kV. I'm also going to be using an Omnibus all-in-one flight controller, and this is version 3. I'm going to be using DYS 4-in-1 20-amp ESC, which is D-Shot 600 capable. Then I'm going to be using a no-name DSMX DSM2 receiver, which I bought from Amazon. And the other main component is the DYS Mi 200mW video transmitter. And lastly, I'm going to be using a Runcam micro FPV camera. The base is actually 158mm, even though they classify it as a 150. And it's not quite 3mm, so 2.8. And 2.2 on all the other pieces. Alright, so now we're going to put the camera pod together, and this essentially forms the top portion of the quadcopter. Obviously someone didn't have Lego when they were a kid. Yeah. Now, and this backwards. There's your pod. Just enough for HS 1177. Now, one very important thing is to put in a battery strap before you start mounting everything, because otherwise you won't be able to do it after. And some people suggest to put 2 just in case you break one. Pretty shallow, but you got that cushioning behind there. This is the battery I'm going to be using. 75C 860. This is a 20 amp, and by putting it this way, you don't have to actually. It basically follows the same motor orientation or configuration, as Betaflight for a flight controller. I'm going to be using an Omnibus F4 Pro version 3. So the version 3 basically has a better regulator, as this green one here. And I'm not going to use the current sensor, okay, even though, you know, really that's the whole point of this board. Here's the SD card reader, slot, whatever. These three little pins here, you have to bridge either these two or these two. If you bridge these two, you'll get 5 volts. If you bridge these two, you'll get battery voltage, VCC, and you'll get them to the where your VTX and your camera are going. So these two pins will be either, depending on what you solder or you bridge, 5 volt, be 5 volt both of them, this is your ground, or, because this is your RAM pin, or the voltage of the full voltage of your battery. So positive here, VBAT from the 4-in-1 ESC DYS, and then you take the negative and you put it on the ground. Very simply. Just disregard this red wire here for a sec. And this on the ground. That's it. And video in is where your TV goes, your camera I mean. Video out is where your transmitter goes. Video, your VTX. This is your ground. And this is your power source. And this is your PWM pin, okay, and then these are your motor pins, starting at 1, 2, 3, 4, okay, 1, 2, 3, 4. So for all S-Bus users and also PPM, ensure that you bridge the top 2 pads accordingly to whichever protocol you're running. I believe for versions 4 and 5 of the Omnibus, you don't have to do that anymore. Also has a 4-in-1 ESC connector, and I forget what the which brand it is that's compatible with this. But I suppose if I had the connector, I could do it and just switch around the wires, but I'm not going to do it that way. Now you got a 5-volt source here for whatever you want to do with it. Okay, so let's just do that again. So we got VBAT. I think it's labeled for you too. We got VBAT. And then we got 5 volt. There should be a black one just hanging around here. Okay. So the ground for the 5 volt is the 4th wire. And then starting from the yellow is motor 1, and it tells you, it designates all the signal 1 to signal 3. So yellow is 1, motor number 1, motor number 2 is blue, motor number 3 is green, motor number 4 is white. I think that's the same as the 30 amp. But this one here has an additional 12 volt and 5 volt hookup. So that's pretty convenient. And for a VTX, I just have a cheap and cheerful DYS Mi 200. The props, I plan on using 30-30 props, these racecraft. I tried the 35-45 bull nose from Dog Prop, and that's just way too much for these motors. It might work on a lower kV version, but, and this is a 4-inch frame. You can actually put 4-inch, but I'm not putting 4-inch props on these motors. I got this DSMX, DSM2 receiver here, which is very light. It's like 2 grams. This is my, it has an F4 brushed flight controller here. I think it's called Swift or something. I forget what this is called. Yeah. It's kind of hard to do with the camera, but Okay, so I put the this nylon mesh. I soldered the EECs. I shortened the wire here, the connector, and now I'm just going to give it a quick clean with some isopropyl alcohol. And it's very important to clean your joints, your solder joints, for any residue, any flux that could be burnt off. I recommend using the flight controller this way, and that your gyro, so that's this one right here, is right in the middle, and you can just change the orientation in the software program. And then you would just put this on here, like that. Oops, wrong way. You could have it this way too, doesn't matter, but there you go. You see how I solder it from in behind so that the wires are not exposed and that they're coming from the sides. So the only thing that's really exposed is this thing, but we'll get that figured out, because that's going to be coming up like this, really. Now I do have to solder underneath that for the VBAT, because the negative goes underneath the positive here. Right, this is your S-bus connection. Then your motor wires start here, 1, 2, 3, 4. Then it has an additional 2 motors, 5, 6. And this is will be a 5 input negative. I wouldn't suggest using any of these, but you can for any 5-volt devices. But if you're using something like I am, where I have multiple 5 volts, just take it from here instead of the flight controller. Alright, first things first, I got all the wires trimmed up. I do need to tin all these little wires here. They're going to go into the motor pins. But before I do that, I have to solder underneath the board the VBAT ground to this ground here, and then the positive. Anti-static devices, and just before we do anything, okay, let's test it out with the smoke stopper. This should give us power to the flight controller. Now if something smokes or this thing lights up, and we got problems. Hopefully there's no problems here. And even the wires, make sure they're not touching anything. Okay, green light. It's all good. Forgot something. I forgot one important thing. Okay. So over here, we need to short these pads. And what I'm doing is I'm trying to get 5 volts. So it's going to be these two here. If you do all of them, the board will fry, so be careful not to. So if you want VCC, you would have done the middle and this last pad here, but I have it on 5 volts. Here's where it gets tough. For me at least. Need some good grips. As you heat the bottom, then you push that through. Number 3. Okay, just like that. Last one. You might have to form it with your finger. Just, you know, make sure that goes straight. But really, is heat the bottom pad, and then the wire, and then push with the wire. There you go. Don't want any pinches here. So that's about it for the motors. Easily clean it up with the iron here. Then we can just snip it a little bit if it's a little too long. Not a problem. Okay, so we got that. We might as well do the one for the transmitter too, for the VTX. Use this. This is the one I use all the time, but for stuff like this, it pulls a little too much. But for this type of wire, because it's not a silicone, if that's the right word, then I don't mind. It works for me. I should make this a little longer. And see, it's pretty convenient. Right, so you want to optimize the size for the hole. And you can see this is a little bit too much. And that's why I suggest make them a little bit longer. See that? How it just juts out like that. This will be much easier to get through the holes. Okay, so I'll heat this and then heat the wire and bam, push through. And I suppose we can do the same with the signal here before I start doing whatever I need to do with the we'll do it again here. So heat up the pad, and then heat up the wire, and then push. And there you go. And then if you have to, usually it's a good procedure to check underneath to see if any of the wires are contacting with one another, just to prevent a short. This is a 12 volt, and I'll be using that for the camera. I was gonna say you can remove them as we solder them, but yeah, okay, let's do that. Let's just remove them. Just make it easier. Alright, so basically all I have is a 12 volt and 5 volt and their respective ground wires. I have some heat shrink we're going to add, and I guess we're going to add it to the longest piece. So what are we going to do first? Okay, let's grab this thing. See, and that's why they differentiate, which is a good, I never thought of it. That's why they use brown for 5 volts. Put some heat shrink in there. I guess we can put it on here. But, you know, wherever fits your fancy. And then I'll put the power. you may be more comfortable with some tweezers or something like that. I don't really care for them. You gotta have a steady finger. Alright. And then the 5 volt. Alright, so that's the 5 volt in. VTX. It's gonna go, oh, we need some heat shrink. What I have here is, and I still have yet to clean it and heat shrink it. So this is the DYS connector that goes to the VTX. I removed the out, the 5 volt out, which is in the middle here. So you only see 4, but there's 5. Trying to get a good camera angle here. There we go. Now I just want to explain real quickly here is that I originally tried to get power to the VTX and camera through the flight controller, but as you will see and as I will show you with the multimeter, that I was not getting the 5 volts needed to power those devices. So this ultimately forced me to use the power source from the ESC, the 4-in-1 ESC. But in hindsight, this is probably the better choice, in that if you can have lesser current running through your board, then I think all the better. And as you can see, this is the original wiring, which I had to remove because I wasn't getting the 5 volts from the flight controller. Full voltage. So this is the pin. So negative, so it's 5. You can see that. Yeah. Not quite 5 though. And this should be the same. I didn't think it would be a big deal while I was testing it, you know, give or take half a volt, but it certainly did. Alright, so I got it working, as you can see from the recordings from my DVR on my Fat Shark goggles. So I did use the, obviously I had to use the data pins here. Okay, so the bottom one here is for the camera. Be careful I don't slice this. And then I have this one for the VTX. It's just on the opposite side. But because I had 2 grounds, I decided to use this ground here to ground it on the board and also on the power distribution board with the second wire. And this camera, okay, I'll tell you, this frame is not fit for this camera. But I'm going to have to retrofit something on the top of it. I'm going to have to put something along here. Now some spare carbon fibers, somewhere parts and junk. or even just screw it directly onto a couple screws here, but I have to have a pretty small screwdriver, and that way this camera is going to be mounted. Oh, there you go, just like that, just like that. So you gotta think it'll be flat like that. You can get the angle. Yeah, nice angle, and be perfectly protected in there. So that's what I'm gonna leave it like that for now. The only thing about this frame I don't like is that the form factor here is part of the structure of the frame. So I kind of have to go a little bit tighter than I want to on these screws, kind of sandwiching the O-rings a little bit too tight. But I don't know. You have to do what you have to do. Okay, so I just wanted to show you this MacGyver kind of proposition for a camera. This is the top plate. So what I did is I just took a piece of plastic from it's really hard plastic to break apart, but it's somewhat pliable, flexible. It comes from those plastic containers that holds your stuff and whatnot. And I just drilled the one hole, not drilled it, I used this little hacker, whatever you call this thing. What do you even call this? And I put the camera up this way. So there's your up tilt. Antenna goes here, and I have a good angle. I did add the Spektrum receiver here. Okay, so just if you have the Spektrum or DSMX, sorry, just use this port here. I got the buzzer, I got the VTX machine to power it on without the antenna, and I'm going to use this antenna here. But before that, I'm just going to put this together. This goes on the bottom, this goes here like that, it goes on the bottom plate like this, back plate I mean, and then here we'll just have to see if it works. And does it look crooked? I'm just going to route the wires through here, make it all nice and neat. So we're almost set to go. I'm just going to put it through Betaflight, and then we're going to maybe hover it here for a bit just to see that the motors are okay, they're not getting too hot, and then we're going to I'm going to try and find a smaller antenna than this. It's a little bit too big. Well, that's pretty much the final product. It looks a little bit, yeah, fruity, but hey, it helps me find it on the grass. These props, by the way, these are Racecraft, I mean, and total they're about 5 grams. These ones are a little bit heavier. They come out to about 9 grams. You can tell they're a little more durable. It's got a little more bulk in the middle here. I did a hover test yesterday night. It all worked. Now on this frame here, I was wondering what the hell this was, but this is just to hold your buzzer, and I have that in place. So it's with the receiver wire here, but this is not a good place for it, so I have to figure somewhere else. Now you saw the actual view that this camera got. You can see the edges of the carbon fiber. So because of this, I don't think I would recommend a micro camera. Polarized lens, here we go. Yes. 196. If I was to use this, which is 400 milliamp, so even this, for example, this 35C 800 milliamp, iFlight, sorry, not iFlight, eFlight. That's 290. Oh geez. Alright, so we got it to 250 grams, that's great, and we're good to go. So before I take you to the last video clip of this quadcopter up in the air, and it's video through my Fat Shark HD goggles, I just wanted to say that I lost this quadcopter right off the start, and that's from not doing a proper range test, and the transmitter that is just a DSMX no name I got from Amazon wasn't that great. It wasn't meant for outdoors, really meant for indoors, and because of that I ended up losing it. I started the flight line of sight, and then when I failed to get orientation I put my goggles back on, didn't realize I wasn't angled. By that time it had failsafe, and I just plummeted to the ground and I wasn't able to retrieve it. So that's my story, and if you enjoyed this video, please give it a like or share or whatever you want to do.